Ever wondered what makes a coil gun, also known as a Gauss gun or electromagnetic accelerator, work so efficiently? The answer lies in the heart of its mechanism, the capacitor. The choice of capacitor can make or break the performance of the coil gun, determining how swiftly and powerfully it propels its projectiles. Firstly, it's crucial to define the requirements of your coil gun. This includes the desired projectile velocity, the size of the coil gun, limitations of the power source, and of course, the budget. These factors set the stage for the selection process of the capacitor. It's important to understand that capacitors are essentially energy storage units. The energy stored is then discharged to power the electromagnets of the coil gun. So the next step involves calculating the required energy storage capacity. This can be done using the kinetic energy formula, half of the mass of the projectile times the square of its velocity. Moving on, the voltage rating of the capacitors should always exceed the maximum voltage of your power source. This is a safety measure to prevent capacitor failure due to overvoltage. A rule of thumb is to choose capacitors with a voltage rating about 20 to 30% higher than the maximum voltage in your circuit. The capacitance of a capacitor determines the amount of charge it can store at a given voltage. A higher capacitance value allows for more energy storage, which in turn leads to increased projectile velocity. However, larger capacitance values also mean larger, more expensive capacitors. It's a balancing act between the desired energy storage capacity and practical considerations like size, weight, and cost. The discharge rate of a capacitor is another key factor. This refers to how quickly the stored energy can be released. Capacitors with high discharge rates ensure rapid and efficient energy transfer to the coil gun's electromagnets. Low equivalent series resistance or ESR capacitors are preferred to minimize energy loss during discharge. The type of capacitor also plays a significant role. Options include electrolytic, ceramic, film, and supercapacitors. Each type has its own strengths and weaknesses, and the choice should align with your specific requirements and constraints. Depending on your energy storage needs and available capacitors, you might need to connect multiple capacitors in a parallel or series configuration. While a parallel connection increases the total capacitance and energy storage capacity, a series connection boosts the total voltage rating. Safety is paramount. Ensure proper insulation and cooling for capacitors to prevent electrical shock and overheating. Choose capacitors with built-in safety features like overvoltage protection and thermal shutdown mechanisms. It's always wise to follow manufacturer guidelines and industry best practices when handling and mounting capacitors in your coil gun design. Finally, once the capacitors are selected and installed, conduct thorough testing and optimization to fine-tune your coil gun's performance. In summary, the process of choosing the right capacitor for a coil gun involves defining your requirements, understanding the energy storage capacity, voltage rating, capacitance, discharge rate, and the type of capacitors. Additionally, the configuration of capacitors, safety considerations, and testing and optimization are also key parts of the process. With the right capacitor, your coil gun can achieve optimal performance and safety, launching projectiles with impressive speed and power.